In 1972, at Marshall University in West Virginia, two students, Ellen Mosley and Lonnie Thompson, met for the first time.
We actually met at a geology party.
At the end of the party, there were two of us still standing, so I took her home.
They had no idea that it was the beginning of their partnership, which would unlock incredible climate mysteries buried deep in ice all over the world. They married and eventually ended up graduate students, researchers, and later professors at Ohio State University and the Byrd Polar Research Center. They are world leaders in collecting and analyzing ice cores.
Ice is probably one of our best recorders of the past.
In regions that never melt, snow accumulates every year, compacting the layers below into ice.
If you look carefully, you can see the air bubbles.
The ice traps anything that was in the air when the snow fell to Earth. Researchers cut small samples of the cores and analyze the air bubbles, dust, pollens, and other elements to construct a climate timeline.
One of the parameters that gives us a very nice seasonal change is the oxygen isotopic ratio, which is also an indicator of the temperature in the atmosphere.
You have a history of volcanic eruptions. You have a history of plants in the pollen. That's why the ice records are so important. I also think they're one of our early warning systems on the planet of change taking place.
98 to 100% of the glaciers being tracked around the world today are either in retreat or already gone. Such a rapid redistribution of fresh water could have profound implications for people who depend on that water or who live near rising oceans. The Thompsons are collecting ice cores as fast as they can before the records disappear forever.
We have over 7,000 meters of core now. To actually think of it as a frozen library. And in many of these places, the record in the real world will be gone.
Collecting ice cores is not an easy job. You have to get to the ice, drill an ice core, and get it back to the lab for analysis. In 1982, Ellen Mosley-Thompson drilled her first ice cores near South Pole Station. But she thought there was better ice to drill. 3 years later, she drilled at Sipple Station. Then in 1986, she took a team to Plateau Remote. But their resupply plane had a problem.
They actually lost us. We could see them in the distance, and they could not spot us on the ground.
They spent 21 days there, short of supplies. While waiting for an airplane to find them, they managed to drill cores, providing a 4,000-year history, a remarkable accomplishment. Meanwhile, Lonnie Thompson was trying to become the first geologist to drill tropical ice from high-altitude glaciers. His first target was Calcaya in Peru.
We first tried to drill it using a drill brought up from Antarctica, and with the power supplies from Antarctica, and finding out that there was no way we could get that drill onto this ice cap.
After that expedition failed, experts feared that the ice cap was too high, and the technology did not exist to drill it. The National Science Foundation decided to give Thompson a chance to develop a workable technology. The Ohio State team developed a lightweight, solar-powered drill and returned to Peru in 1983.
This was my second attempt, and I figured if we failed, I would need a new career. But in the end, the drill worked beautifully.
Since then, Thompson has used his solar-powered drills on dozens of glaciers, painting an astounding story of climate events on each continent. For example, this 3,700-year-old black band in a core from Mount Kilimanjaro shows dust from a major drought. It was likely the drought described in the biblical story of Joseph and the famine in Egypt. The Thompsons worry about how humans will adapt to our warming world.
Frankly, nature doesn't care about any of us, and it will continue to change no matter what we believe. If you live in a part of the world where there's a glacier, you don't have any doubt that the climate is changing because you can see it.
We know what the pre-anthropogenic concentration of carbon dioxide and methane in the atmosphere have been.
Since the Industrial Revolution, carbon dioxide concentrations are double what they ever were for the last 1,000,000 years. But the Thompsons remain optimistic.
Human beings can work together under the worst conditions on Earth to accomplish a goal. When our backs are to the wall and we have no other choice, we're likely to do the right thing.
The 2012 Benjamin Franklin Medal in Earth and Environmental Science was presented to Ellen Mosley-Thompson and Lonnie Thompson for their collective studies of ice cores from around the world, which have improved the understanding of Earth's climate history, including the role of the tropics in global climate change.